How did the discovery of isotopes change atomic theory? Imagine thinking every atom of an element is exactly the same, with a fixed weight. Then, scientists find atoms of the same element with different weights. This discovery changed everything. In the early 1800s, John Dalton proposed that atoms were tiny, indivisible particles, each with a specific weight. He believed that all atoms of an element looked alike and had the same mass. But as scientists studied radioactive materials and measured atomic weights more carefully, they noticed strange variations. Some samples of the same element showed different atomic weights. Frederick Soddy, an English chemist, realized these differences meant atoms of the same element could have different numbers of neutrons. These atoms with the same number of protons but different neutrons are called isotopes. Soddy's work proved that atoms could come in different forms, or isotopes, which kept the same chemical behavior but had different masses. This idea explained why atomic weights varied depending on the source of the element. For example, some forms of uranium had different atomic weights but behaved chemically the same. It also meant that atomic weight was not a fixed number for each element. Instead, it was an average based on the isotopic mixture. J. Thomson, famous for discovering the electron, also separated isotopes of neon by their mass. He initially thought the heavier form was a new element but later understood they were isotopes of neon. This was the first time scientists physically separated isotopes, confirming their existence. The discovery of isotopes also helped explain the structure of the atomic nucleus. Protons determine an element's identity, but neutrons add to the mass. James Chadwick discovered neutrons in 1932, which explained why isotopes of the same element had different masses. This deepened the atomic model by showing that neutrons are neutral particles inside the nucleus. Knowing about isotopes has had many practical uses. It is vital in nuclear physics, medicine, archaeology, and chemistry. Radioisotopes are used in medical imaging and cancer treatments. Radiocarbon dating helps archaeologists find the age of ancient objects. Isotope labeling allows scientists to track chemical reactions precisely. In summary, discovering isotopes changed atomic theory by showing that atoms of the same element can have different masses. It shifted the idea from atoms being identical units to a more detailed picture where neutrons vary but chemical properties stay the same. This milestone opened new doors for science and technology, shaping how we understand matter today.